Hey guys, I'm back and I'm going over 10.7 as per request. I'll go back to 10.3, 4, 5, 6 later. We're going to cover quadratic surfaces, and like I promised in the 10.2 video, this one is quote unquote better quality. And by better quality, I mean I put pictures. So first we have our ellipsoid, and I highlighted the things that make this an ellipsoid. So we also have our squares, but we have plus, plus, and then equals. It doesn't necessarily have to be a 1. It could be any number. Just know that this number here is going to be your r squared. And don't forget that a squared and b squared and c squared could be a thing. And if you need some review on conics to understand what all of these variables mean, I would highly suggest going and looking at some videos on that too. But I tried to draw this shape for you to help you picture it. It's kind of like a football. I darkened out the outlines as much as I could to help you see like the outside of the shape. Sadly, I'm not that great at drawing, and I had to make the picture bigger so it's a little hazy. But that's what an ellipsoid looks like, and there's the formula. If you're writing this down, you can pause the video if you still need more time, but I'm going to go on to the next one to show you the pattern. So here you see that we have the elliptic cone, and we have z squared. The squared is important. And x squared over a squared plus y squared over b squared. And the a is greater than 0, b is greater than 0, because otherwise this doesn't really work out too well for you guys, having a 0 in the denominator. And again, I drew the picture for you, and I darkened out the outline to help you see it. Again, I'm not the best artist, but it helps you visualize what you're seeing. And if you want some help on graphing these things, again, I'm going to have to send you to someone else's videos because I don't really consider myself qualified to help with graphing. Not even sure if I'm qualified to be helping with what I'm helping with now. So elliptic paraboloid, and I want you to just look at the picture for a second and note how this is very similar to what we just saw. Very similar. And now if you look at the equation, you see, not looking at the z, because obviously you already see the difference as there's missing a square. But over here, the x, a's, y's, b's are exactly the same. The only difference between these two is z is not squared here. But this is what it looks like. It looks like a bowl. Or if it's upside down, it looks like a dome. I like to call it a dome. But it's an elliptic paraboloid. Alright, so our next shape is going to be everyone's favorite shape, the saddle. Just kidding, it's called a hyperbolic paraboloid. Y'all really need to learn the proper name for this thing. And the difference here is we have z not squared, and then we have whatever this variable will be. For this case, it's y squared. It could have its x squared there. This z could be an x, but just know that the variable here is going to be to the first power, and it's going to have a minus here. And of course, a is greater than 0, b is greater than 0, because like I said, that's not going to work out too well for you otherwise. And this is what it looks like. I kind of showed you how to graph it in a way by saying, okay, so in my YZ plane, I have just this little parabola here, and in the XZ plane, I have this parabola here. And then you just kind of picture these extending along this parabola, and it creates a saddle. And we have to remember that the point in the middle, where z is 0, is going to be called the saddle point. Or not necessarily z is 0, but whatever your variable here is. And now we have our hyperboloid of one sheet. There's a few ways you could picture this. You could picture it as a piece of paper just kind of rolled up. Or if you know what plant Bowen is, then it kind of looks like the smokestacks. Just a little bit, if you know what I mean. Anyway, so we have x squared over a squared plus, just remember the important things are the things I highlighted. The variables could be in whatever order they want. Y squared over b squared minus z squared over c squared equals 1. The 1 is important, because if we don't have this positive 1, we're going to have this negative 1 with the plus and minus. And the negative 1 tells us we have a hyperboloid of 2 sheets, which kind of looks like our elliptic paraboloid, but there's like 2 of them. It's interesting, actually. But that's because whenever you're doing your hyperboloids, they have like the little 2 lines, or not 2 lines, but basically 2 lines, and it like reflects itself, if that makes sense. Like I said, if you need graphing help, I'm not really good at that, and you should probably seek better help. But this is just to point out the patterns in the equations and get y'all to be able to picture these things. In a parabolic cylinder. So what we notice here, I couldn't really highlight it because it doesn't exist, is that z is free, which means that this shape here extends forever. But I wasn't going to draw a forever extending shape because I can't really do that. And if you look at this and you go to your YZ plane, you see that y is going to be x squared over 4a, and that gives you something like this. I kind of just sketched it out. And this is what a parabolic cylinder looks like. It's a parabola that extends for a long, long time. So what does that mean an elliptic cylinder is? Well, it's an ellipse that extends for a long, long time. And here you have a plus, and you have whatever your radius will be here, your radius squared. It doesn't have to be 1, that's why it's not highlighted. So now, what about hyperbolas? You got your hyperbolic cylinder, which has a minus instead of a plus, which says, hey, reflect, essentially. And this is kind of what it looks like, or this is what it looks like in this case. It just has the same formula as this, but with a minus, but the same kind of shape as this. You could also think of it as having half of this, and then this half being carried to where it reflects. However you want to do that. But I'm just kind of trying, like I said, to give you the patterns to help you be able to see these shapes, because that seems to be what a lot of people need help with the most. But anyway, guys, that's gonna be my quick 10.7 run through, because that's mainly just memorization. And if you need help graphing, I personally can't help you, and I don't want to teach you wrong, so I'm not going to attempt to teach you that. But I'm glad you are watching these videos, and I hope you enjoy. See ya!